Why is quantum entanglement called spooky action at a distance? Imagine two particles that are connected in a way that no matter how far apart they are, what happens to one instantly affects the other. Sounds like science fiction, right? But this is exactly what quantum entanglement is. Albert Einstein called this phenomenon spooky action at a distance because it seems to defy the rules of classical physics. In classical physics, nothing can travel faster than the speed of light, including information. Yet, entangled particles seem to communicate instantly, even if they are on opposite sides of the universe. Quantum mechanics, the branch of physics that studies tiny particles like electrons and photons, explains how this works. When particles interact in specific ways, their quantum states become linked or entangled. For example, if two particles are entangled in terms of their spin, measuring the spin of one instantly tells you the spin of the other. This happens even if they are separated by vast distances. It's as if they have a secret connection that no one can see or explain easily. This idea challenges what we know about how the universe works. Classical physics says objects are only influenced by nearby things, and causes must happen before effects. But entanglement seems to break these rules because the measurement of one particle instantly influences the other, no matter how far apart they are. This puzzled Einstein and his colleagues Boris Podolsky and Nathan Rosen. They created the EPR paradox to argue that quantum mechanics might be incomplete, and that hidden variables could explain entanglement without breaking the rules of locality. Later experiments, especially those inspired by John Bell's theorem in the 1960s, proved that entanglement is real and fundamental. These experiments showed that particles can be entangled even under extreme conditions, like with unstable particles such as top quarks. This means entanglement is not just a theoretical idea, but a real feature of nature. Today, scientists are using entanglement to develop new technologies. Quantum computers relying on entangled particles to perform complex calculations much faster than traditional computers. Quantum cryptography uses entangled photons to send secure messages across thousands of miles, because any attempt to eavesdrop on the communication instantly changes the state of the particles, revealing the intrusion. In simple terms, spooky action at a distance is how Einstein described the strange, instant connection between particles that defies our everyday understanding of space and time. It is a key milestone in the formulation of quantum mechanics and has changed how we think about matter and energy. This discovery continues to push the boundaries of science and opens up exciting possibilities for future technology.